Parallel and perpendicular lines, algebraic models. Some definitions that we'll need. Parallel lines are lines that are in the same plane but do not intersect. Slopes of parallel lines are equal. Two non-vertical lines are parallel if they have the same slope and are not the same line. Any two horizontal lines and any two vertical lines are parallel. Any two lines are perpendicular if their slopes are negative reciprocals of each other, and any vertical and horizontal lines are perpendicular. So example number 1, we're given the equation form of two lines and we're asked to determine are the lines parallel. So our strategy will be to write both equations in slope-intercept form, since we're focusing on algebraic models in this video. You'll notice the first equation is already in slope-intercept form, where the slope is -4/3 and the y-intercept is 5. The second equation has to be fixed up so that it is in y equals mx plus b form. Okay, let's subtract 4x from both sides. Now let's divide all three terms of the equation by 3. And now I want you to imagine if you were graphing these lines, you would start with the y-intercept, then you would use the slope. And since both lines have the same slope but different y-intercepts, the two lines are parallel. Here we're asked to write an equation in slope-intercept form for the line that passes through the point -1, 1 and is parallel to a line with the equation y equals 2x minus 1. Now if I had a graph, I would plot that point -1, 1, and I would remember that parallel lines have the same slope, so I would use the slope of 2, and from the given point I would go up 2 to the right 1, up 2 to the right 1, etc. I would connect it, and I would see if the line goes through a clear y-intercept. And that's how I would write the equation in slope-intercept form. But without graph paper, we can start with the point-slope formula. Y minus y1 equals m times x minus x1. Now the x1 and y1 will be substituted with -1 and 1 respectively. And I'm using 2 because we're looking for a line that is parallel to the line y equals 2x minus 1. Now let's use the distributive property. Let's add 1 to both sides, and we will get y equals 2x plus 3. Now go back to the prompt and make sure that it makes sense with what was given. Is this line going to be parallel to y equals 2x minus 1? Yes, in fact it is. And does it go through the point -1, 1? When you plug -1 in for x and 1 in for y, do you get a true statement? And yes, we do. All right, third example. Are these lines perpendicular? And here we're given 2 points, and the line 1 goes through those 2 points. Line 2 goes through those 2 points. Without a coordinate plane, we could use the slope formula, y2 minus y1 over x2 minus x1. Okay, let's substitute in our values for line 1 to find the slope. 0 minus 4 over -3 minus -5. And let's simplify that fraction and simplify the denominator, and we get a slope of -2 for line 1. Now, if this is going to be perpendicular to line 2, then line 2 should have a slope that is the negative reciprocal of -2. So let's figure out the slope of line 2. And now let's simplify the numerator and the denominator. Let's combine those integers. And because these two lines have slopes that are respectively -2 and 1/2, then yes, the lines are perpendicular since their slopes are opposite reciprocals. So notice we solved that problem without the coordinate plane, but by using the formula for slope. Example 4, we're writing an equation in slope-intercept form for a line that passes through a given point, -2, -3, that is perpendicular to a line with an equation y equals -3x plus 1. Well, let's start with the point slope formula. And let's think, what are we going to substitute in place of x1 and y1? We'll substitute -2 and -3 respectively. And the slope that we'll use, the m, will be positive 1/3, which is the negative reciprocal of the given line. Now let's simplify the equation and apply the distributive property. And now let's subtract 3 from both sides. And here we end up with an equation y equals 1/3 x minus 2 1/3. So it was helpful that we had the algebraic model, because I hope you would agree, if we were to graph the line that was described, it would be difficult to identify the y-intercept if it's a fraction. All right, we have one more example, and it deals with coordinate geometry. Use the slopes of the line segments to show the triangle LMN is a right triangle. Okay, now if it is a right triangle, which two segments would be perpendicular? And use inspection to determine that. We are considering the slope of LM and MN. First, the slope of LM. Using your slope formula or simply rise over run, we get -4 as the slope of segment LM. Now the segment MN. Using rise over run or your slope formula, we get 1/4. Are those slopes negative reciprocals? If so, then angle M is a right angle because the lines are perpendicular. The slopes of segments LM and MN are negative reciprocals. So therefore the two sides are perpendicular, and triangle LMN is a right triangle because it contains a right angle. So today we talked about parallel and perpendicular lines using algebraic formulas primarily.